So let's take this motion diagram that we just generated for two possible motions. The first one, this upper one, the man started at -10 and moved with a velocity of +2 meters per second and an acceleration of 0, and we did a motion diagram with the delta t of 1 second. And the second one is with the man on the right side at +10 and with a velocity of -10 meters per second. And again, the acceleration is 0 and the same delta t. So let's look at both of these motions as graphs. And so let's put the man at -10 to do the first motion and set the velocity at +2. We'll click this on, and then let's take these walls away. And I want to show you now what the position, velocity, and acceleration, well, that's set to 0, so that's not going to be very interesting. So let's just go ahead and play this and see what we get. Okay, that's probably good enough. So what you see here, the horizontal axis for all three of these plots, position, velocity, and acceleration, is time. And so this one, the middle one, velocity, is flat because the velocity is constant. And so that's flat at 2 meters per second. The fact that it has 0 slope means the velocity is not changing. The position, on the other hand, starts at -10, and in every 2 seconds it goes 2 meters to the right, as we can see from this motion diagram over here. And so if you go over 2 seconds, that corresponds with the 2-second scale that you see down here. At that point, the man should have gone 4 meters to the right, which is going to put him at -6, consistent with what you see on the graph. And so the important insight here is that for constant velocity, the position is a straight line with a slope, and the slope of this line is the velocity. It has a positive slope corresponding to this positive velocity, and for every 1 second over, this goes up 2 meters, which corresponds to a 2 meters per second velocity. So now let's change things, and let's put the man over here. Let's go ahead and reset everything. Let's put the man over on the right side, and let's set this to -2. And now we're going to look at a graph of the second displacement option that we chose here. And so let's start that up, and you'll see another plot now. Okay, I'm going to let the blue line go to the bottom there and then stop it, because it's going to go off scale at that point. Okay. Now, similar comments here. You can see again that the velocity is constant, and it's -2 meters per second, and so the slope of the velocity curve is 0, which means the velocity does not change. On the other hand, the position has a negative slope corresponding with this negative velocity, and in fact, for every 1 second that we go over here, this drops by 2 meters, corresponding to the -2 meters per second velocity that we have. And so now we have well, two different ways of representing motion. We can use a motion diagram, and we can also use a graph. And so the next thing we want to talk about is are the equations for each one of these. And so let's do that on a separate YouTube.